Hi, I'm Guang, 15 years old, secondary 3 finance high school. Here we have a lesson on limit theory and its applications. And we're still looking into the epsilon delta method. Alright, so in the previous lessons we already had a few examples to show how exactly you can use the epsilon delta method. But in this lesson we would have two more examples to show how we can further use it. So in the first example, we have limit x approaches to 0, e to the power of x is equal to 1. Well, if you just solve it, it is pretty obvious. E to the power of 0 is just 1. But now we need to show that this is equal to 1. So how are we going to solve this? Of course, the epsilon delta method. But there will be a few different things which you'll see later on. So let's get started. Now, firstly, of course, we would still have given epsilon, this is greater than 0. While you have this epsilon greater than 0, there exists delta that is greater than 0. Alright? So, how do we find epsilon? That would be e to the power of x minus 1. And this is smaller than epsilon. Okay? Since when you have a difference, you want whatever value you have to be closer to your tendency than this epsilon, okay? So, e to the power of x minus 1 smaller than epsilon, greater than negative epsilon. E to the power of x smaller than 1 plus epsilon greater than 1 minus epsilon. So, what would you have to do next? Now, since our delta would actually be of x minus 0, which you actually want x. Now, can you think of any methods in order to find x? Well, of course, logarithm. So you could take ln on every side. So you have ln 1 minus epsilon, then x smaller than ln 1 plus epsilon. Alright? So, from this part, you will realize two different logarithms, but which one should you take? Now, here is where we are going to determine which one we are going to take. But if you have realized, we do have another layer of modulus around both of these, since there is a possibility, or it is pretty much this value that comes out would be negative, while this value is positive, alright? But you can't just compare a negative value and a positive value since it will be pretty obvious. But instead, you want the exact value without the sign, alright? So that is what we are going to compare between these two. So one easy way to understand this comparison would be by the drawing of its graph. So what is so special about its graph? Normally we'll see this, right? Okay. So ln 1 minus epsilon and ln 1 plus epsilon starts from 1, which ln 1 is 0. So it starts from 1. Then let's say 1 minus epsilon. That means it moves back a bit and you have a value over here. While for the plus, it also has this little bit and you get a value. Alright, so what is so special about these two different parts? So what do you realize just by looking at this? Now it does seem like this part below is further from the point you have than the positive part, right? Now is that really so? Well, one easy way to show that it is correct is by finding its gradient. Since just by looking at the graph, you can pretty much tell that the gradient is always decreasing. Since it's always decreasing, that means from this point, if you move to the left, it drops faster than when you move to the right and it increases. So since this drops faster, it would have the further distance away from the point that you have. Now, in this case, do we want the further one or the closer one? We want the difference to be smaller. So when we want the difference to be smaller, we take the point that is closer. So here it would actually be the other way around, not smaller, alright? So we want the point that is closer. That means we can let, what do we let? We let delta be ln 1 plus epsilon. Okay? So this will be our delta. So when, so you have x smaller than, you can write x smaller than delta or just smaller than this part, limits x approaches to 0, e to the power of x would be equal to 1. And so we have shown that this is correct. Alright, so this will be for your first example. Well, you have to show limit x approaches to 0, e to the power of x is equal to 1. Right, now that's the first example. Let's take a look at our second example. Now I'm just going to remove this part. Alright, in our second example, we have limit x approaches to 1, 3x plus 1 over 2x minus 1 is equal to 4. So this is pretty easy to solve, but let's get proving. So again, we would be having, given epsilon greater than 0, there would exist delta that is also greater than 0. So first things first, 3x plus 1 over 2x minus 1 minus 4, this is smaller than epsilon. Alright? So this part is smaller than epsilon. Now, how about we make some operations within your modulus that you have, which is to combine the two. So what happens if we combine the two? So 2x minus 1, 3x plus 1, so minus 8x and plus 4, smaller than epsilon. So you would be seeing negative 5x plus 5 and over 2x minus 1, like this, alright? So how about we divide the 5 onto the other side? Well, also, since this is a modulus, that means you can change negative x plus 1 into x minus 1, since you have the modulus. Now comes the problem. How do you find delta? So there are a variety of ways you can choose to use, but first of all, let's let. So what are you going to assume? Now, since x approaches to 1, how about x minus 1? Now, what does this need to be smaller than? Well, of course, for different values, you can go ahead and try on your own whatever kind of values you want. But in this case, how about 1 over 3? So of course, you have to be aware of every case. Well, sometimes they could be solvable, sometimes they can't. Or even if it seems solvable, it could become very complicated with many different cases that you have to consider. So let's consider smaller than 1 over 3 in this case. Now, x minus 1 is smaller than 1 over 3, greater than negative 1 over 3, so x is smaller than 4 over 3 while being greater than 2 over 3. So that's pretty obvious for now. Now, in this case, what are we going to see? Now, how about let's change the 2x minus 1. So, 2x minus 1. Now, 2x, that means you have 4 over 3, but 4 over 3 minus 1 is 1 over 3. Now, 8 over 3. 8 over 3, so 5 over 3. Okay? So these will be the two different parts that you're going to see. But which one do we use? Okay, let's think about it. We want x minus 1 to be small. We want it to be small. That means this part you would also want it to be smaller, isn't it? Now, how exactly do you make that happen? Now, if you multiply this to the other side, that means you want it to be as small as possible, which means you would have to use 1 over 3, alright? So, when you take 2x minus 1, or just let that be 1 over 3, that means what you would be seeing is, so 1 over 3 in the denominator, that just becomes, well, you could write 3x minus 1, or you could also just move your 3 to the other side, which creates epsilon over 15. Alright? So you would have these two separate cases, which in the end you would consider with delta equals minimum between 1 over 3 and epsilon over 15. Well, of course, again, in this case, epsilon could be like 100, 25, 10, 1, 0.1, whatever, right? But wait, now you would have to still be aware that this is approaching to 1, right? So that is one thing you want to keep in mind. But other than that, so when your x minus 1 is smaller than delta, limit x approaches to 1, 3x plus 1 over 2x minus 1 would be equal to 4. Alright, so that would be how you solve a question from this case over here. Well, of course, yeah, you can just keep on experimenting with different values. Alright, so I hope in this lesson, for these two examples, you could understand both of them. Alright, so again, it is pretty much just, if you extend it out, it will be seeming like a trial and error kind of thing. Or if you want to call it like exhaustion, alright? So you give one value, okay, you want to satisfy it, isn't it? So I can give you some other values that will satisfy this condition. Oh, you want to change it again? So you made the condition even more stricter, but you could still find more values that can satisfy, and this keeps on going, which we can just show it in this form, right? So as long as this is satisfied, this would be true, or you could also write shown. Alright, so I hope this lesson is clear until now, and I'll just be ending it here. So thank you for your watching.